All right, let's see if I can do this on the first try this week. Hope y'all are doing well. Meant to send this out yesterday and things got crazy. But Fan 5 last week was awesome. I'm hoping the videos helped at least somebody. Um, because the scores were really good. I think we had over 80% of the kids getting fives. Had a ton of fours mixed in there. And the best part is I think 90 it was like 96 or 97% of the kids improved. So from Monday to Friday, if that score goes up, obviously that's the goal. And this week, I told them on Monday, I told them yesterday, like there's gonna be zeros and ones to start the week. We're probably not gonna have many people get fives, but to me, these are the best fan fives because you really get to see your score improve, and you have to earn it. Like I've showed them things in class that if they're not taking notes and they're not using them, it could be hard to get that score to go up. But seeing it for a few days and trying to use the strategies that I'm showing them, like already today, like I had a student go from a 1 to a 5 this morning. It was awesome. And I had almost half the kids try a certain strategy that I showed them in class. And you don't have to use them, but if you're somebody who's missing a question, Monday, Tuesday, Wednesday, to me, it's at least worth a shot. So here's a perfect example of Fan 5. We've got some spiral review in here from things they learned in third grade. Question like number 2, that's something we're doing in class currently. And then number 1 is a good pre-teaching example. So I'm gonna walk over here to the whiteboard. Hopefully you hear me. So number 1 is this is called a multiplicative comparison question. So anytime the kids see the word times as many, a couple things should come to mind. One should be, hey, this is a multiplicative comparison. And then it should be the way that we solve it. The thing that I do, I show them this all the time, is something I call the box method. So with a multiplicative comparison, first thing we got to do is we're going to pull the two things out that are being compared. For this example, I'm comparing Charlie's toys and Albert's toys. So here's Charlie, here's Albert. And then this part's really important. The question says, how many toys does Albert have? That means I know that Albert's going to be really important for this question. All right, so it's called the box method for a reason. We're going to draw boxes. That comes from this right here. If it says 3 times as many, somebody's getting 3 boxes. If it said 9 times as many, somebody would get 9 boxes. But if it says Albert has 3 times as many, that means Albert's going to get 3 boxes. And once you've got the big number of boxes settled, the other person automatically gets 1. So I've used this number right here, and now I'm going to have to use this number. It says together they have 16 toys, meaning it doesn't just belong to Charlie, doesn't just belong to Albert, it belongs to both of them. So I kind of draw a bracket, and I know that all of those boxes together is equal to 16 toys. But my goal is I want to take those 16 toys, I want to split them in between all those boxes. Well, they're learning pretty quickly when I say split, I mean division. And if I'm splitting between all those boxes, I see 1, 2, 3, 4 boxes. Now, if you notice in the question, there is no 4 up there. But we got that from using the picture. We got that from the box method. If they know their facts, or if they know 4 times something to give me 16, they would know that answer is 4, which means I'm putting 4 toys in every box. The star is really important because somebody might say the answer is B because we put 4 in every box. Well, that's not what the question was asking. I wanted to know Albert, and if I added all those up, 4, 8, 12, that would have given me C. I told them that's not something you're going to do the next day and get it right, even though one student did blow my mind and did the box method perfectly this morning. It's something that's going to take practice, but man, if you do it, it's so helpful. Those multiplicative comparisons, you're going to see this in Fan 5 a ton because it's a struggle every single year for our kids. So we'll get tons of practice with multiplicative comparisons. All right, let me get my mouse on here. All right, question number 2. We're doing a lot of place value stuff in class, just comparing numbers in general. This one says, how many times bigger is the 4 in the number 45,293 than the 4 in 3,402? There's a hard way to do this, and there's a really easy way to do it. One thing that I've been telling them, anytime I'm comparing numbers, I'm always going to stack them. Kind of setting it up like I'm going to do an addition or a subtraction problem. line up the place values, and just stack them on top of each other. All right, in this particular question, I'm looking at the 4s. So I want to know how many times greater the top 4 is than the bottom 4. So the hard way you could do this is figure out what those 4s are worth. Like I know that's in the 10,000s place and there's 4 of them. So that's worth 40,000. And I know this is in the hundreds place and there's 4 of them. That would be worth 400. What they could do is they could say, hey, would 400 times 10, 400 times 100, or 400 times 1,000 give me 40,000? And in reality, it's not that much more difficult to do that because you're really just adding zeros. But instead, what I told them in class is this. 10 has 1 0, 100 has 2 zeros, 1,000 has 3 zeros. What you're going to do is you are going to jump and move this 4 until it lines up with that other 4. So if I took one jump and I moved that 4 to the thousands place, they're not lined up. If I took an extra jump and I moved it to the 10,000s place, then they would be directly stacked on top of each other. If you took 2 jumps, 100 has 2 zeros, that's your answer. If I were to take 3 jumps, 3 zeros, it would be 1,000. I can actually show you that. If I was comparing the 3s, how many times greater is the 3 in this number than this number? Okay, I'm just going to count my jumps. 1 jump, 2 jumps. It would take me 3 jumps to line up. 3 jumps, 3 zeros. So look, I'm all for it if you want to figure out those values and do that math. If it were me, I'd stack them and jump. That one actually went up. Like we had 19 out of 22 get that one right this morning. So that's awesome. All right, number 3 is spiral review. I'm on these kids pretty hard about knowing their facts. Like I got pretty high expectations with multiplication. Hopefully we're still at home studying. But if we're looking for all the factors, meaning all the numbers I can multiply to get 24, they should be pretty quick to get rid of B because the first factor pair I want them to think of is 1 times the number itself. So that gets rid of B. At this point, there's a couple different ways they can solve it. If they want to like make their factor rainbows, they can do that. Or if they just kind of want to eyeball them and say like, ooh, I know that number's not a factor. But like if you look at A, 1 times 24, 2 times 12, 3 times 8, those all work. Most important word here is all. I got the numbers in front. 6 people chose A on Monday. Like their math is good, but that is not all the factors. And I'm wondering if maybe they just didn't even look at any answer choices after that. Because if you look at C, you got the same exact factors on there, but you also got to have 4 times 6. So if you don't know your facts and you don't know all your factor pairs, this question could be difficult. For D, they could probably look at that and say, hey, I know 10 is not a factor, but they could also do their factor rainbows and know that 3 times 10 would give them 30. So a bunch of different ways you can do that one. Like that one was 11 on Monday in my homeroom and 17 today. 17 out of 22 is not terrible, but that's one I think like we just got to know our facts. And it's coming. In time, the more we practice, and we practice a ton, that one will get better. All right, number 4. This is spiral review from 3rd grade. And it's kind of similar to stuff we're going to do this year. It just said, what shape has 1 set of parallel sides? I introduced them to the word intersect because a lot of them were saying, hey, parallel sides will never touch, they'll never cross, which is true. But we're going to use the word intersect a lot, kind of part of our academic vocabulary. But if you know they're never going to touch, I told them the only thing you have to know about a trapezoid is it has 1 pair of parallel sides. I call it the lonely quadrilateral. The top and the bottom would never intersect. But if I were to go on the sides, up top, they're eventually going to meet. So that answer was D. We also talked about how a square has 2 pairs. Talked about how a rhombus has 2 pairs. And a hexagon actually has 3 pairs. You got the bottom, you got these sides, you got these sides. We looked at these on Monday. Today we talked about an octagon and a rectangle, I think. But this one actually had the same numbers as number 3. We went from 11 to 17. So numbers going up, which is good. But as long as they know parallel sides never intersect and they know how to find them, that one we should be pretty good on that one. All right, number 5 was probably my favorite question on here because even though we haven't done it, I know they did it in third grade. It says, which picture below shows a pizza that has 3/4 left? First thing we had to figure out is what that meant. Like, I had a lot of kids who were trying to say pizza was gone is what was left, but I told them to look up at the pictures. Like, look at B. How many pieces do you see left? And they would say 2. The 1 represents what got eaten. So this word right here is going to change every day. Like today it was eat or it was eaten. If I want to know what's left, I want to know what I can see. So I'm looking for 3/4 left. What we did with A was we found out there were 6/8 left here, 2/3 left here, 1/4 left here, 1/3 left here. Most people who missed it chose D. And it at least makes sense to me, but that 3/4, that's what got eaten. I wanted to know what was left. So some kids panic and they chose D because it looks close. But if we are 100% sure that we've got the right fractions on the board, and I know I'm looking for 3/4, I don't have to guess. That just means one of those answer choices is going to be equivalent. And we talked about some of their teachers might call the butterfly method. I just call it straight up cross multiplying. I can take my answer choices, 6/8, 2/3, 1/3, 1/4, and I can take the 3/4 that I'm looking for and just set it right next to it, toss my multiplication sign in the middle, and go bottom to top. Boom, boom. So I go 8 times 3, 24, 4 times 6, 24. They look completely different, but they represent the same amount. So 6/8 is my answer, and I can prove that that's the only one that's equal, because 3 times 3 is 9, 4 times 2 is 8. 3 times 3 is 9, 4 times 1 is 4. 4 times 3 is 12, 4 times 1 is 4. So sometimes they're going to have to find a fraction that is equal to the same amount. But what's crazy is, I'll just kind of show you, I'll show you what we did today. Like today's question, it says, which picture below shows a pizza that has 1/3 eaten? So I told you that word's going to change. But some kids made this so hard because if we're talking about what got eaten, that's what's gone. So we know this is 2/8. This is 1/3. This is 3/4. This is 2/3. We're looking for 1/3. 1/3's right there. I told them today, just circle it. You're done. I had like 5 or 6 kids who were cross multiplying that one. If you see your fraction, just pick it. You don't always have to cross multiply. But for the instance of what we had today or what we had on Monday, we didn't see our fraction, so we did have to. Let me walk back over. So the numbers have not been pretty to start the week, and they honestly weren't supposed to be. And that's how it's going to go sometimes. And I don't really care what their numbers are Monday. I did care today. Like, if I see you going from a 1 to a 2, sweet. Love that. Just want you to continue going up. The only thing that bothers me with Fam 5, some kids will sit there and not take a single note. Like, if you're not taking notes, it's different. You could be watching me and just soaking it in like a sponge. But if I see you consistently not taking notes and then not improving, I mean, that says a lot. So ultimately, if your child wants that score to go up, they know exactly what to do. And I'll answer any question they have. I probably go over these for too long just because I know how important Fam 5 is. But hopefully this helps. Holler at me if you have questions. I'm anxious to see where we end up at the end of the week. So if you're watching, thanks for watching. If you watched this whole video to this point, send me an email or a message on the Facebook page. Send me something, and I will give your child tickets. That's a great idea. Don't tell people. All right, bye.